All right, folks, any questions? Okay, so um, we had to move some things around in order for us to keep on track and allow us to catch up after the big snowstorm. Also, one of the things I did was I moved things around in lab based on your feedback that you wanted to take the practical after we come back from spring break. So what I did was we're going to start Unit 3 today. We're going to be looking at 3 tests that help to differentiate the enteric bacteria, and that's the oxidase test, the phenylalanine deaminase test, and the decarboxylase test. And then when we come back on Thursday after the exam, for those of you who want to meet with me in lab, we'll go over McConkey agar, EMB agar, and Hector enteric agar. You do not have to. You can choose to skip that day, but you can watch the video. You're still responsible for material, but I know after the test you may not want to think too much about technical things, right? And these are pretty technical. Okay, so we're going to do this first, and then we'll have time to talk about a review if you guys want to. So we start with the oxidase test. The oxidase test is really important to differentiate gram-negative bacilli, right? And we're going to differentiate them as those things that are oxidase positive, right? So those things that are oxidase positive. And if they're oxidase positive, they're going to be things like Pseudomonas, which is clinically relevant. Pseudomonas and Oxidase. And those things are aerobic. And those things that are oxidase negative, which are the ones that we're really going to be interested in. And those are the enterics. And I'm not going to write them because there's a whole bunch of them, but they're the enteric group, right? And those things are facultatively anaerobic. And there'll be things like E. coli, Shigella, Salmonella, Klebsiella, Citrobacter, Proteus, a whole bunch of different ones, okay? So if we think about this, it's a real easy test to run, right? And these are some examples of the Enterobacteriaceae, the enterics, right? So you can see Citrobacter, Edwardsella, Enterobacter, Escherichia, Shigella, Uinella, Hafnia, right? Klebsiella, Morganella, Proteus, Providencia, Salmonella, Serratia, and Yersinia. So you can see that there are really only 3 true pathogens: Shigella, Salmonella, and Yersinia. E. coli, certain strains of E. coli are pathogenic, but not all. Most E. coli are not dangerous at all. Okay. So you guys know about Salmonella and Shigella. You've heard of them, right? Cause dysentery, bacterial dysentery. Yersinia, you may not have heard of, but this one causes plague. This is bubonic, pneumonic, and septicemic plague. We're not going to talk about it until we talk about infections at the end. But the ones that we're going to talk about are the rest of the guys on this particular list. Enterics are characterized by being a gram-negative bacilli. They ferment glucose. All of them ferment glucose, right? They are reducers of nitrate to nitrite, but then they stop there at step 1, and they are all oxidase negative, which is an important way to differentiate them. It's a really important and quick way to differentiate them. Okay, so we have this oxidase test, and the oxidase test is real easy. It's looking for the presence of cytochrome C oxidase in the electron transport system, right? Some of them show up, some of the tests can be little strips like this. Some of them are kind of a liquid reagent that you put some of the colony on a cotton swab, and then you saturate it with the reagent, and then if it turns purple, and within 15 seconds or so, then that's positive. Okay. Here's the reagent. It's NNNN, tetramethyl phenylalanine diamine, right? And so it's a redox indicator, and what it's looking for is the presence of that particular enzyme, right? So from now on, I'm going to let you cheat just a little bit, so that when I ask what's the reagent used in the oxidase test, all you're going to have to answer is the oxidase reagent, and we're going to mean that thing when we talk about the oxidase reagent. And that's just too big to remember. And can you imagine writing that on a practical, and how many people would kind of misspell that? Right? That's an amazing word. Okay, so we're going to say it's the oxidase reagent. Okay, so turning purple after or within 15 minutes is positive. If there's no color developed within 15 minutes, no color, right? No color, then it's negative. And it's that easy, right? So it's just a little piece of strip of paper. You take a little bit of the colony with a toothpick or something, you rub it onto that area, and it turns purple within 15 seconds, positive. It doesn't turn purple within 15 minutes, and it's negative. So we at Riverside use the spot test, right? And so the spot test, all you do is you take a swab, cotton swab, you take a little bit of the colony, and then you add a little bit of the reagent. It's in this little kind of ampule. You put a little bit of the reagent on there, and you wait for about 15 seconds. It's going to happen quickly. When you put it on there, it immediately starts to turn purple, right? Now you have to be careful, because if you walk away for, say, 5 minutes and you come back, Mick, and then you see your swab is purple, you might say it's positive, but how quickly did it change, right? It has to be within 15 seconds. So if it turned later than that, because there's so much oxygen out here that it's eventually going to interfere with the reagent and look a little bit purple, right? So you just have to be careful. So this is one of the more important slides of the entire presentation. And so what you see here is kind of the analysis, right? If a purple color develops as purple, that means it's an aerobic bacterium, and it's a non-enteric, right? Where if there's no color and it's gram-negative, right? So that it's negative for oxidase, it's a facultatively anaerobic bacterium, and therefore we put it into the enteric bacterium. But remember, it has to be a gram-negative bacillus in order to be put into this category. Okay, good. Because lots of people talk about enteric bacteria, and they'll talk about cocci that are enteric. Yeah, but that's not the enterics that we know as being pathogenic, right? We're talking about gram-negative bacilli. Okay, so this is an important slide. You should know this, right? And here I am a little bit more professional here. I'm wearing my lab coat. I don't remember what I was doing that day. I even combed my hair. Look at that. So you guys can watch this video. It's embedded, but if you can't see it, then here is the link that you can put it on to your browser and take a look at it. You can also go, of course, to the YouTube channel and watch it there. You don't have to join the channel if you don't want to. It's okay. I don't get paid for it, so it's a resource for you. Are there any questions about the oxidase test? Where is this PowerPoint located? It's located underneath Practical 3, underneath the slide that says enterics. Okay? All right. So let's review. Define enteric for me. What are the 4 characteristics that define enteric bacteria? Somebody.
Gram-negatively.
They're gram-negative bacilli, correct? What else? Hello?
Glucose fermenter.
They ferment glucose. What else?
Reduce nitrate to
They're reducers of nitrate to nitrite, step 1. And what's the last one?
Oxidase negative.
Oxidase negative. Very good. Very good. So what is the oxidase reagent called?
Oxidase reagent.
Oxidase reagent. Thank you, Maria. Very good. And what constitutes a positive oxidase test?
The purple coloring.
And within how many seconds?
15.
15.
Very, very good, very good. And if it's a purple color, is it aerobic or facultatively anaerobic?
Aerobic.
Aerobic. And is it enteric or non-enteric?
Enteric.
Non-enteric. Non-enteric. That's right. And enterics, by definition, are oxidase negative. Okay? Good. So this differentiates the organisms as gram-negative bacilli that are enteric or non-enteric, right? And that's an important step, especially when you're trying to define what the pathogen might be. Okay? Very good. Let's go on to the second test. Second test is easy. It's called the Phenylalanine Deaminase Test. And what we're looking for here is the ability of a microorganism to really deaminate. And when you deaminate, what you do is the enzymes will remove the amino group, right? So the amino group gets removed and it immediately is not happy. So it picks up another hydrogen and it forms ammonia. And when ammonia is added to anything, it becomes more basic, right? But here we're going to use it colorimetrically to look for the end product of that deamination, which the amino acid phenylalanine gets deaminated. The amino gets removed and it becomes phenylpyruvic acid. And we can look for that very easily colorimetrically. Okay? So here again, if you think about it, right, we're looking for the enzyme phenylalanine deaminase. If it comes in there with water, it's going to remove the amino group and you're going to have phenylpyruvic acid, right? We can add ferric chloride to it, and ferric chloride is going to interact with the phenylpyruvic acid to form a green color. So if you have a green color, it's going to be positive for the test. Any other color is going to be negative. Okay, so here you have it. So it's typically in a slant. And so tell me how you're going to inoculate the slant. What are you going to do to a slant?
You use the inoculating needle.
Yeah, but what's the process called? What's the process called?
Streak the slant, stab the butt.
Thank you very much. That's correct. Streak the slant, stab the butt. So you're going to come in here with your loop or your needle. You'll streak the slant, and then you're going to stab the butt. Okay? You incubate at 37 degrees Celsius, 98.6 for you guys who like Fahrenheit, for about 24 hours. You come back, and you add about 5 drops of ferric chloride. If you add 5 drops of ferric chloride and it turns green, it's positive. Any other color is negative. Okay, so here's the test, right? So you can see that after 24 hours, you add ferric chloride, about 5 drops. If it turns green, it's positive. Any other color is negative. So sometimes it looks yellow, sometimes it looks rusty orange, doesn't make a difference. Any other color that is not green is negative. Okay? Any questions? So there's a video here for you guys to watch if you want. It's not my video, so I just borrowed it from the web. It's an easy video to watch. It gets into a lot more detail than I did, and all you need to know is what I've told you, right? But I want y'all. Some people learn better by watching videos, and so you can watch this video because it's being recorded, but you can also watch another video because sometimes it's okay to get another perspective. It's okay. But if we look at this, then you can see the results here, right? This is a control, right? It's not inoculated. Okay, this is E. coli. It's inoculated. You can see it's kind of rusty orange. Any color that is not green is negative, and here you can see Proteus mirabilis had turned green after we added ferric chloride. So green is positive. Any questions? Let's review. What is the principal substrate in the phenylalanine deaminase test? What is the principal substrate? Elvira, tell me. Elvira.
Is it the phenylpyruvic?
Phenylalanine.
No, the phenyl.
Phenylalanine. That's right.
Yeah.
That, phenylalanine. Yeah, that's what it is. So listen. In a lot of these tests, if you know the name of the test, you sometimes know the substrate, right? So for instance, check it out. Phenylalanine Deaminase Test. Phenylalanine is the substrate, right? The nitrate reduction test. Nitrate is the substrate, right? Are you with me? The carbohydrate fermentation test. The substrate is the carbohydrate. Starch hydrolysis. Starch is a substrate, right? So if you know the name of the test, you a lot of times know the name of the substrate. Okay, so this particular test is typically found on a slant. How are you going to inoculate the slant?
An inoculating loop or needle.
And what process are you going to use? SSSP, very good. And you come back, you incubate it for 37 degrees Celsius for 24 hours. You come back and you add 5 drops of a reagent. What's the reagent you add?
Ferric chloride.
Ferric chloride, very good. And what constitutes a positive test?
Green color.
Green color.
A green color. These things are not hard. Okay. Questions? All right, let's move on to the last test, right? Here I am being a happy guy. So this one I got photobombed. You can see people sticking out their tongues back there and making faces. But I'm talking about the phenylalanine test. This is the way my labs are. My labs are always very, very interactive. People walk around. Mick knows, she's been in them, right? Yeah. So Mick knows, she's been in them. So my labs, people learn a lot because they get to do a lot, right? And so I'm sad that you don't get to see and be part of it, but yeah, the labs can be a lot of fun. Anyway, we're going to talk about the decarboxylase test. And then in the decarboxylase test, there are 3 possible substrates. They are arginine, right, which is an amino acid. Arginine. It can be lysine, another amino acid, or ornithine, another amino acid, right? So these are not in the same tube. Each one of them have their own separate tubes, okay? And we're looking for the ability of a microorganism to really decarboxylate, to break apart the molecule. And if they do that, they're going to release this thing into the environment. And what is this thing? What is this thing? What do you think? Brenda, what is that thing?
Is
Leo,
that
what is that
ammonia?
thing? It's an amino, no, well, it's an amino group, but you're right, it's not happy. And so immediately, not nitrite, but this is an amino group. It immediately is going to pick up another hydrogen. It's going to be ammonia. And when ammonia is added to anything, does it change the pH to become more basic, more acidic, or more neutral?
More basic.
More basic, right? So it's going to become a much more basic environment, right? And so we can use that. We can use that change in pH, right? We can use that change in pH to help us to elucidate what the test means, right? So the 3 possible substrates are lysine, ornithine, or arginine, okay? In the test, it's real easy to do, right? But in order to do the test, you have to do a couple of things. Number one, when you inoculate the organism into the broth, you can see there's a setup here with an arginine, lysine, and ornithine. You have to do each one for each organism. when you inoculate the organism in the broth, you have to make it anaerobic. And the way we make it anaerobic is we have some sterile mineral oil that we sterilized, and you just simply add the mineral oil to the meniscus of the tube. And because it has a different viscosity and it is going to be more nonpolar, it's not going to mix with water, it's going to form this seal on the surface of that particular broth. And so it's going to make that broth anaerobic. It's the only way that the test is considered valid, right? If you do not make the test anaerobic, it is not valid. You can't really have a result of a test if the test is invalid. So if you see a decarboxylase test with no mineral on top, it's just simply invalid. It's no good. Okay, you can't guess from what the results might be because they're all going to turn purple, right? And the reason they turn purple is because besides the substrate in here, there's a pH indicator, a new pH indicator that's called bromocreosalt purple. Bromocreosalt purple at alkaline conditions, which is positive, is violet. At neutral conditions, it's amber, negative, right? This is neutral. And then at acidic conditions, it's yellow. But these guys are both negative. The only positive is if the media turns violet. And why is that? Why is that? Mick, why does the tube turn violet? Liz, help her out. Mick might be getting some coffee somewhere.
Because it became basic.
It became more basic, right? And so remember, at basic conditions or at alkaline conditions, it becomes violet. So violet is the only positive test. Everything else is negative. Okay? I'm sorry, I'm having to drink electrolytes because when I got up a little bit ago, my quad started to cramp. I'm like, oh heck, I'm dehydrated. So I'm drinking electrolytes and water right now. Hopefully in a couple of days I'll be back to normal. Any questions so far? All right. So you have to remember each of the different substrates. So here, every organism is going to have a different biochemical profile, right? So here's Enterobacter cloacae, right? And we've set it up with arginine, lysine, and ornithine, but you can see that the arginine is positive, but the lysine is negative and the ornithine is negative. They're not violet. Okay, good. So this one would Enterobacter cloacae is positive for arginine, but negative for lysine and ornithine. And that's important to help us to distinguish the organisms. Okay, so I do have a video, and this is a video that I didn't do, but I borrowed it. And so here is the link to the video you can watch, right? At some point I have to get back in the lab and make my own video. Okay? Any questions? Okay, so let's practice. So if I label these tubes A, B, and C, what's the result of B?
Negative.
What's the result of A?
Negative.
Negative.
And what's the result of C?
Negative.
Positive.
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 Positive. Are these tests valid?
Yes.
Yes.
Why? Why?
Because it has the sterile mineral oil.
Okay, good. So, and it's created an aerobic environment, yes or no?
No, it's anaerobic.
It's an anaerobic environment. Okay, very good. Very good. Any questions about the decarboxylase test? What's the pH indicator? What's the pH indicator?
Is it alkaline?
Oh, that's the pH of this tube, right? This is alkaline, right? But what's the pH indicator? What allows us to see a change in color?
Bromocresol?
Bromocreosol purple. That's right. Don't just say bromocreosol because it'll be wrong. But you have to say bromocreosol purple. Okay? Good? Everybody, anybody have any questions about the decarboxylase test? Okay. These are the easy ones. The harder ones come on Thursday when we talk about McConkey, EMB, and Hectorwin. Okay? Anybody have any questions? Okay, I'm gonna